Hey everyone, welcome back to The Explainer. Today we're tackling something I know a lot of you deal with constantly, that critical jump from a developer's local laptop all the way up to massive enterprise-scale production. If you're living in the cloud-native world, you already know the two absolute heavyweights here, right? Docker and Kubernetes. But here's the kicker. As we scale up that infrastructure, we absolutely scale up our risk along with it. So let's just dive right in and unpack exactly how scale completely changes the security game.
I want to kick things off with this fantastic quote from Professor Russell Esposito. He says, "Docker builds the container, Kubernetes runs the fleet." It just perfectly nails the dynamic we're looking at today. We've got the builder on one side and the commander on the other. It's a massive shift in purpose and scope, and man, that shift literally rewrites the rules of engagement when it comes to securing your apps.
All right, so here's our roadmap for today's explainer. First, the container foundation. Second, Docker as the local builder. Third, Kubernetes running the fleet. And finally, the security trade-offs. Let's get to it.
Part 1. The container foundation. Fundamentally, whether we're talking about Docker or Kubernetes, they both exist to package, deploy, and run applications in isolated, reproducible environments, right? The secret sauce here is process isolation, done through namespaces and cgroups. That is the absolute bedrock. So whether you've got just one container spinning on your laptop or you're pushing 10,000 across a huge data center, this basic, fundamental unit of isolation, it stays exactly the same.
But, and this is a huge but, you've got to remember that containers share the host kernel. This right here is the inherent vulnerability of all containerization. Unlike full virtual machines, containers are definitely not perfect, impenetrable sandboxes right out of the box. A single kernel exploit, yeah, that can break that namespace isolation entirely. And if that happens, an attacker suddenly has access to the host, plus literally every other container running on it. Not good.
So because of that shared kernel risk, there's a baseline of security you just have to adopt right from day one. We're talking verifying your image provenance, enforcing strict vulnerability scanning, and making sure you implement least privilege configurations. And let's be clear, this isn't some optional add-on for Kubernetes or a nice-to-have for Docker. No way. These are mandatory table stakes for literally any container environment, anywhere.
Moving on to part 2, Docker, the local builder.
Let's talk scope. Docker builds and runs containers on a single host. It's really hyper-focused on the developer's local workflow and CI/CD pipelines. Contrast that directly with Kubernetes. Kubernetes is out there orchestrating containers across massive clusters of hosts, and its brain is focused entirely on production-scale operations. It's a totally different beast.
And naturally, this difference in scope changes the fundamental unit of deployment. Docker operates mostly at the single container level. Even if you're using Compose, you're still really dealing with individual containers. Kubernetes, on the other hand, gives us the pod abstraction. That's one or more tightly coupled containers that are scheduled and executed together as a unit. So Kubernetes is basically already thinking in terms of grouped, scalable resources instead of just standalone processes.
Now the real beauty of Docker, and honestly its greatest security asset, is its simplicity. It's easy to learn, it's super quick to get running locally. And because it's mostly operating on a single machine as just a container runtime and image builder, well, there are simply fewer moving parts. And as we all know in the security world, fewer moving parts naturally means a significantly smaller attack surface. It keeps things contained.
All right, part 3, Kubernetes running the fleet. This is where things get wild. When we make the jump to a multi-node platform supporting hundreds of nodes, the complexity just absolutely skyrockets. You're not just securing a tiny container anymore. Suddenly, you've got to harden the etcd data store, you've got the kubelet agent running on every single node, there's the central API server, the controller manager. I mean, the operational overhead just to run and maintain all this stuff correctly, it is massive.
And because of that, the stakes go through the roof. On a single machine, a breach is definitely bad. But in Kubernetes, you're looking at a production attack surface where a cluster compromise can wipe out many nodes and countless workloads all at once. This is exactly why network policies and really strict namespace isolation become absolutely vital. If an attacker gets a foothold, you have got to have the defenses in place to stop that lateral movement across your fleet.
Which brings us to part 4, the security trade-offs. Let's dive into some of the double-edged swords here, starting with the scaling trade-off. Kubernetes gives us this amazing feature called horizontal pod autoscaling, or HPA. It basically spins up new pods automatically based on CPU, memory, or whatever custom metrics you want. It's pure magic for handling sudden traffic spikes. But think about the flip side.
If the image it's scaling has a zero-day vulnerability, or worse, if it's already compromised, your autoscaler is just going to efficiently and rapidly copy-paste that compromised image across your entire fleet in seconds. It's a terrifying thought, right?
So how on earth do we defend against that? Well, you can't just turn off autoscaling. That defeats the purpose. The answer is that you always have to pair HPA with robust image signing, using tools like Cosign, for example, and really strict admission policy enforcement. You literally need to guarantee, cryptographically, that the cluster is only ever allowed to pull and scale images that your security team has explicitly vetted and signed off on. Okay, let's look at the next double-edged sword, the self-healing trade-off. We love that Kubernetes automatically restarts failed pods, reschedules them on healthy nodes, and replaces unresponsive containers. For uptime and availability, it is an absolute lifesaver. But from a security perspective, this self-healing can actually easily mask attacker-induced crashes. Think about it. If an attacker is just blindly firing memory corruption exploits at your app and crashing it over and over, Kubernetes is just going to quietly restart it every time, completely hiding the attack from a casual glance. To stop this masking effect, your visibility has to go way deeper than simply checking if a pod is running. You have to combat this with strong centralized logging, comprehensive audit trails, and active runtime threat detection. You need a system that's going to actively tap you on the shoulder and say, hey, not only is this pod down, but it's restarting suspiciously often. You might want to check this out.
The networking models are also a pretty stark contrast. Docker mostly relies on basic port mapping, and you usually need external tools if you want any real load balancing. Kubernetes, though, it uses built-in service abstractions to give you internal load balancing and DNS-based service discovery right out of the box. Now that's incredibly powerful for microservices for sure, but it also means your internal network is highly dynamic and interconnected, which creates a very rich, complex internal attack surface if an intruder ever manages to bypass your perimeter.
And this really brings us to the underlying theme of this whole explainer. In Kubernetes, complexity is literally a security risk. The learning curve is steep, and that directly translates into misconfigurations. The most common breach vectors we see in Kubernetes, they aren't usually crazy zero-day exploits. Nope, they're human errors. We're talking misconfigured RBAC, accidentally exposed administrative dashboards, or overly permissive service accounts that basically hand a compromised pod the master keys to the entire cluster kingdom.
Because of this immense complexity and the sheer operational overhead, running Kubernetes securely demands a strict set of mandatory fleet defenses. You have got to relentlessly harden your RBAC and API server access controls. You absolutely must implement etcd encryption at rest. You need TLS mutual authentication between all your cluster components. And you've got to enforce continuous compliance scanning to catch any configuration drift way before an attacker even sniffs it.
So as we wrap things up today, we come right back to that core dynamic. Docker builds the container, and it does it with a small, manageable footprint. Kubernetes runs the fleet, handing you these incredible automated superpowers, but demanding intense, rigorous operational security in return. Sure, the tech can scale your applications instantly, but the real million-dollar question you have to ask yourself is this. Kubernetes can run the fleet, but is your team genuinely ready to secure the complexity? Thanks for hanging out with me for this explainer, and I'll catch you on the next one.